right, hello everybody. Welcome back. So today we are going to be starting on deep water currents here. Okay, we finished talking about upwellings and downwellings and gyres, and if you need a refresher, make sure you go back to the other video in which we covered these PowerPoint notes. But today we are starting on deep water currents. So first thing we want to talk about, what is a deep water current? Well, we talked about shallow water currents, and shallow water currents are those currents that are driven by wind. Okay, they are the currents probably with anywhere from 1 to 3 meters deep. Now your deep water currents, those are anything 3 meters and deeper, and those are caused by thermocline circulation. And thermo, think, means temperature. So it's the changing of the temperatures. We've talked about the hot water and the cold water, and how hot water, like in your home, hot air will rise to the upper floors and cold air will sink. Same thing with water. The warm water will rise and the cooler water will sink. And what this will do will actually cause a deep water current. It's almost like a convection current. Okay. This also is caused by waters of different densities. And we talked about this in the water lab, temperatures and densities and their effect on water and the movement of water. Okay, so wind pushes warm surface waters away from the equator. Okay, so we talked about those surface currents. So now we have the water moving away from the equator towards the poles. This causes an upwelling of deep, cold water at the equator. So it's pushing the warm water away. The cooler water is replacing it, moving up. And the dense, salty water at the poles now sinks sinks down. So the warm water moves away from the equator. It's replaced by the cooler water. And then the dense water now at the pole starts to sink, and you have this giant convection current going around and around. So again, we see this thermocline circulation. It's based on temperatures. It's based on the hot water and the cold water. The hot water will rise. We have that heating, just like the air in your home. Hot water rises, cold water sinks. All right. This cooler water is denser, so it also falls. As it gets over here, it loses its density. The heat makes it rise near the equatorial regions, near the equator. It travels from the equator over to the polar regions. It falls and keeps on doing this convection current. Again, here we go. This is a wonderful example. We have the equator right here. The water moves from the equator out towards the poles, up towards the North Pole, falls because it's denser, it's cooler. It comes back, it replaces that warm water that has been pushed out, and we see this circular movement of water. The same thing occurs in the southern hemisphere. It moves out from the equator towards the poles. It sinks because it's denser. The cold water moves back towards the equator. It rises because it's less dense. It starts to warm, and then it moves again. Remember, these are called upwellings. Here, upwellings at the equator and downwellings near the poles. So hopefully this has helped you a little bit. The next thing that we are going to get into is waves and tides. And with regard to waves and tides, you're going to have to go onto your computer and upload a little simulation. You're going to watch that, and you will also be creating the waves quiz while watching that simulation. So hopefully this has helped you guys, and I will see you again in another video. All right, bye everybody.